Today we're going to look at section 1.12, modeling variation. Okay, we're going to look at direct variation first. Direct variation is y equals kx. You're going straight across. K is the constant of proportionality. And x and y are variables. So direct variation, we'll also hear it say varies directly. So we're going to look at page 123, number 1. During a thunderstorm, you see the lightning before you hear the thunder because light travels much faster than sound. The distance between you and the storm varies directly as the time interval between the lightning and the thunder. Suppose that the thunder for a storm 5,400 feet away takes 5 seconds to reach you. Determine the constant of proportionality and write the equation for variation. So we're looking at direct variation. It says distance between you and the storm varies directly as the time interval between the lightning and the thunder. Okay, so the first thing we're going to look at is direct variation, y equals kx. So ours is distance equals time times k. This is on page 123, example number 1. So, again, looking at the words, it says the distance between you and the storm varies directly as the time interval between the lightning and the thunder. So, suppose that the thunder from the storm is 5,400 feet away, takes 5 seconds to reach you. Okay, so where are we going to put? The 5,400 is going to go in for the distance. And the 5 seconds is going to go in for the time. So now we're solving, and we're solving for what? We're solving for k, which we said was called the constant of proportionality. So we're going to divide by 5 on both sides. This cancels out to be 1, so we get k equals 1080. This is 5 divided into 5,400, so if you used your calculator or divided it out. So we're going to take the k and put it back into the formula. So distance and time, we're going to let d be distance, k is going to be our 1080, and time is going to be our t. So that would be our first question. It says the thunder is 5,400 feet away, takes 5 seconds to reach you, determine the constant of proportionality and write the equation for the variation. So now this is our equation that we can use now to find other things. So this was the A answer. The B answer, it asks us to sketch the graph, but we're not going to do the graph, so we're going to go to C. C says, if the time interval between the lightning and the thunder is now 8 seconds, how far away is the storm? So now where is the 8 going to substitute in for it? It's time, so time is equal to 8 seconds. So we're going to put the 8 in for the t. So I'm going to get distance equals 1080 times 8. So we get 8,640 feet. Now, if we wanted that in terms of miles, the first one was in terms of feet, so we have it in terms of feet. But if we wanted it in terms of miles, what would we have to do to find the number of miles? Well, this is the distance in feet. We know that there's 5,280 feet in 1 mile. So to take and find it in miles, we're going to take 8,640 and divide by 5,280. And that's going to tell us how many miles. So if we rounded to the hundredths place, we would get approximately 1.63 miles. So direct variation is straight across. The second kind of variation that we're going to talk about is called inverse variation. So inverse variation is the second one. So inverse variation is of the form y equals k divided by x. So the first one was multiplied by x, the second one is divided by x. And we're going to say this could be written as inversely proportional So now we're going to look at page 124, number 2. So give everybody a chance to go to that page. Another way that this one might also be written is varies inversely. So anytime the word inverse or inversely is used, then we know that it's going to be a division. So this one says, Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas is inversely proportional to the volume of the gas. Okay, so reading it again. Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure is inversely proportional to the volume. So we're going to say pressure equals K over volume. So this would be pressure of the gas, volume of the gas. So that's our general equation. Then it says, suppose the pressure of sample of air that occupies 0.106 meters cubed at 25 degrees Celsius is 50 kPa. Find the constant of proportionality and write the equation that expresses the inverse proportionality. Okay, so our pressure is 50. Our volume is 0.106 meters cubed. So now we have a proportion. We have two equality of two ratios. So to solve a proportion, we're going to cross product. So K times 1 gives me K equals 50 times 0.106. So now again, if we use our calculator, 50 times 0.106 gives me K equals approximately 5.3. Now, when we take this 5.3, what are we going to plug in for? We're going to plug in for K. So we have K P is pressure, equals 5.3 over volume. So pressure and volume, just like we had up here at the top. Pressure equals K over volume. Pressure equals K over volume. The second question it asks is for if the sample expands to a volume of 0.3. So we have a volume of 0.3 that it's expanding to, 0.3 meters cubed. So what are we going to do with this volume to find out the pressure? It says find the new pressure. Well, we're going to put the 0.3 in for the volume then, right? So we're going to have pressure equals 5.3 divided by 0.3, which is going to be approximately 17.7. So if I were checking answers on this, this would be an answer I would be looking for, the word form. This would be an answer I'd be looking for once we found K, so probably K would be an answer I would be looking for, and then this would be the next answer. So we've got direct variation and inverse variation. Now, we can take these things and we can combine them where the same problem has a variation of inverse and direct. So now we're going to look at an example, combining the variations of the different types. So an example might be S equals KXY. So this is jointly proportional or varies jointly because we've got an X and a Y. So jointly proportional. But you can also have one that's directly proportional to some variable and inversely proportional to another variable. So that's what we're going to look at next, is example, page 125, number 3. So we go to page 125, example number 3 says, the apparent brightness of a light source is directly proportional to the luminosity, L, of the light source, and inversely proportional to the square of the distance from the light source, measured in meters. Okay, so let's read it again. The apparent brightness of a light source measured is directly proportional to the luminosity, L, of the light source and inversely proportional to the square of the distance from the light source. Okay, so now we're going to say brightness, so B for brightness. It says that it's directly proportional to luminosity, so that would be our KL for direct proportional, direct variation. And then it says inversely proportional to the square of the distance. So inversely puts it in the bottom and it's got square of the distance. So directly to L, inversely to the square of the distance. Does everybody agree with that? So the next question says, if the distance is doubled, by what factor will the brightness change? Okay, so if the distance is doubled, so we have B equals KL, but instead of having D, what would it have to look like for it to be doubled? Doubled implies twice what D is. So I'm going to have 2D. So I'm going to plug into the formula. For D, I'm going to plug in 2D. So 2D squared. So what happens if it's doubled? Times it by 2, right? So I have B equals KL, and if I square this, the 2 is squared and the D is squared, so I get 4D squared. So the first one was KL over D squared, but now I've got KL over 4D squared. So it's going to differ by a factor of 1/4. So it's 1/4 the brightness of the original one. So differs by a factor of 1/4. So the distance, if you double the distance away from it, then it's going to be the difference of a factor of 1/4. So you'll have 1/4 of the brightness. Dividing by 4 is the same thing as multiplying by 1/4. So this would be 1/4 KL over D squared. So the K over D squared is the same, so the 1/4 would be 1/4 of the brightness. Now you can go to page 130 and 131, and it's going to give you some formulas for chapter 1. So if you turn to page 130, it gives you properties and formulas. So there's a lot of stuff to look at for chapter 1. So let's look at a few examples on page 127, the page that you're going to do your assignment on. The first one we're going to look at is number 7. It says t varies directly as x. So directly means straight across, so I've got t equals kx. And that's my answer. So that one's not hard. The second we're going to do is number 10. Number 10 says W is proportional to the product of M and N. So W equals K M N. That's one of those jointly ones, right? Doesn't go on the bottom because it doesn't say inversely. Okay, let's look at number 25. Number 25 says W is inversely proportional to the square of R. So that's the first part. W is inversely proportional. So all of them have a K. See how all of these have a K? But it says inversely to the square of R. So number 25, reading it again, W is inversely proportional to the square of R. So inversely because it's on the bottom. Now, this is the first answer, but the second on 25 has a second part to it. It says if R is 6, then W is 10. So if R is 6, then W is 10. So we're trying to solve to get K then, right? So we put this over 1. Now we have a proportion. So we're going to cross product. So I get K times 1 equals K. 36 times 10 is 360. So now we go back and we plug our K in and gives me W equals 360 over R squared. And that's the notes that we're going to do right now for section 1.12.